Yesterday, right? We have class with you, and we explain what is the application of Fourier series. Now you will see in the next slide, we will derive a formula, and in that derivation, we use the Fourier series for simplification. Okay, we neglect the higher order term. You see, we will use only this amount in the Fourier series, because the value of h, if is very small, then you square it, you'll get smaller value. So we can ignore the smaller value. Higher order term. And still, you see, we are not 100% right, because you are not taking all the term from the Fourier series. So what you sacrificing? Accuracy, right? That means we make a assumption here. But how we'll know that our theory is right? That's why you will do the experiment, you will do the test, and you work in the lab. This is one more example I am giving you, that why you have a lot of lab class. Okay. So in the next slide, we'll derive a formula that how you can figure out pressure of a fluid at a certain depth. For example, you have a bucket of water, and you like to figure out the amount of pressure at the bottom of the bucket. You can figure out without formula, because if you know the volume of water, you figure out the weight, then divide by the area, weight by area, you will get the pressure. Okay. Somebody's mic is to mute. Kausar Ahmed, okay. So you can figure out the pressure easily, but you have a C and upper surface of C. What will be pressure at the depth of say 2 kilometers or 1 kilometer depth? I will figure out the pressure. In that case, you are not able to measure the quantity of water. You cannot figure out the weight, right? But we are able to figure out by a formula. What is that formula? If this height is h and density of the fluid is rho, then pressure right over here, it will be P equal to h rho g. That means pressure depends on depth of the location and density of the fluid, and also gravitational constant g, right? In this formula we will derive. Now I can just give you this formula, but still you need to know how this formula came in. I just make in home overnight, or it came in from the mathematics. Okay. Again, what is the fluid mechanics? We apply the law of engineering mechanics to the fluid. So you'll see how we'll apply those law in fluid mechanics in the next derivation. Okay. So we'll measuring a formula, or we derivating a formula to measure the pressure. So right over here, it gives some introduction about the pressure. It's saying normal force exerted by a fluid per unit area of the surface is called fluid pressure. It is noted that it is if an imaginary surface assumed within a fluid body, the fluid pressure and pressure force on that imaginary surface are exactly same as acting on any real surface. For example, you have a pond in your home. So you like to put something under a depth h from the top surface of the pond. This is the top surface, and this is the bottom surface of your pond or lake. And you like to keep something at a height, this height. And you need to know that how much pressure will be right over here. So how we can figure out? You have option that you put first that object at the bottom in the pond at a, for example, at a height 2 meters. Then you measure the pressure, right? Instead, you just think on your table that, okay, I like to put something at the bottom of the lake at 2 meter depth. So my pressure will be, I'll use this formula. E equal to H rho G. So this formula you are applying, that is actually the by ideal formula based on some assumption, right? But this amount of pressure and reality, you got the pressure, both will be almost same. Again, nothing is 100% right. So there might be some variation, 0.5% or 1% or 2%. Okay, so that it's saying if you imagine a surface in your mind, then you do the mathematical calculation, you will exactly get the same pressure. That is saying, for example, you are designing a submarine and it will, staying under the sea, say about 3.5 kilometer. And what will be pressure? Top surface of the submarine, at the roof of the submarine. So submarine is not here, but you can calculate the amount of pressure from your reading table by using this formula. Okay. Now, how we can derive this formula? At first, we need to consider a fluid element. A fluid element, it might be a triangular, might be a prism, or might be a cube, but it has finite volume, dimension non-zero. It has a density and also pressure, and it has a weight. Nothing you can ignore. Okay, so we are talking about static fluid. Static fluid. Fluid is not moving. So if you consider a fluid element at the bottom of your lake or pond, I am thinking a cube, rectangular, square cube, and all dimension, or you can think it a rectangular, no problem, like a brick. Okay, so obviously it has a volume, it has a density, and inside it has a pressure, it has a weight. So weight will work directly downward, right? So this cube is remain, or fluid element remain static condition under the lake. But why remain static? Still it has a weight. So it is not moving upward, it is not moving to our right or to our left. So we need to figure out that what type of force is working in that fluid element, and how much will be pressure right at the top surface of the fluid element. Okay, so we will think you say right over here, infinite small fluid element. That means very small fluid element, dimension of each side, dx, dy, dz, at a point in a static mass of fluid. And let's P the intensity at the center of the element. That means we think that the center of the element pressure is P. Now we will derive this formula. Okay. So before we start, I just give you fundamental idea that how we will derive, right? So what I am thinking that at the center of the cube, right, pressure is P. Pressure is P right over here. How much pressure will be left side and right side? How we can figure out? Another thing, we need to figure out a coordinate system. So along this direction is Y, this direction is X, and vertical direction is Z. Now, in the cube, if I look in the front view, so right over here, pressure is P. I like to know, or I like to figure out how much the pressure will be right over here and right over here. How will you figure out? By mathematics. Anyone? What is this distance from here to here? From here to here, distance is dy, right? So what is the distance from center point to this point? dy by 2, right?
Yes, sir.
And this one also dy by 2, these two. But y is increasing along this side, right? So you know the value, pressure at a distance x. So not x, y at a location. But what will be the pressure right in the right over here? What you can use? First, we will use the Taylor series, because this location we know the pressure, and we need to know what will be the pressure at x plus h distance. So what will be the h in that case? H will be my dy by 2, the right side. But if I consider the left side, then what will be my h? In that case, h will be minus dy by 2. Okay, this is my H. Then we will use the Taylor series, figure out the pressure right over here, right over here. Similarly, along this direction, along X direction, yes, center pressure is given. So we can figure out the pressure, right, this surface and this surface by using Taylor series. Okay, just refresh your mind again that right over here is the Taylor series. You know value at x. What is the value at x plus h? Okay. Now, if you found the pressure right over here and right over here, you found the pressure, then you can easily figure out the force in that side, because pressure equal to force by area. So your F equal to pressure times area. And you see, if I know the pressure over here, I can get the area. It is dx into dz. So I get the force. Similarly, right over here, on the left side, area will be same, right? dx into dy. Then you multiply with the pressure, you will get the force. So this fluid element is expressing force from this side and also from this side, but it is not moving. What does it mean? Summation of force equal to 0 along y-axis as per engineering mechanics. Similarly, we will use summation of force along z-axis equal to 0 and also along x-axis equal to 0. Okay. So far, any question? No? Okay. And we'll derive the formula by using other file, that is MathCAD file. That will be easier to understand. Okay, did you see the file? Hello?
Yes, sir.
Okay. Now, before you derive the formula, you need to make some assumption. What assumption? You will think the fluid is ideal, no viscosity. Fluid is static, not moving. This is one assumption. And you considering a very small fluid element with dimension dx, dy, dz, and pressure at the center of the fluid element is P. That will be your assumption. So every formula you derive, at first you need to have assumption, then you derive the formula. So most of the time, what I see, the student directly derive the formula. Even I see you don't draw the figure. So even you are right, you write all the equation, but you are doing without drawing figure. You are deriving without assumption. Then what will happen? Your mark will be deducted. So sometime you say after exam that my answer is right, why I got a less number. So those are the reason. Okay. Similarly, in the cube right over here, somebody drawing very nicely and somebody drawing like he don't know what is drawing. It is a brick, but he make it a circle, sphere. And how he'll get the mark? The mark will be reduced. Okay. So let's see how we can derive. Okay. At first, I put the Fourier series again over here and some formula that P equal to F by A. So F equal to PA. Now, at the center, pressure is P. I need to figure out pressure this side and this side. So in that case, my H will be dy by 2, dz by 2, dx by 2. If you figure out the pressure right over here, then your H will be minus dy by 2. But if you figure on the right side, at the positive side, your H will be positive dy by 2. Okay. Now, let's draw the cube that you might easily understand. So this is the cube, right? Along this axis is y, right? I'm not writing, just look in the figure. This axis is z, along this axis x. Now, I like to figure out the pressure. Could you hold down one thing? That this file is little bit shortcut. Okay, let me see. I might have a one more file that has more explanation. Let's see, 1 second. Same file, but did you able to see the file? Hello?
No, sir.
No? Okay. So let me stop the sharing and start it again. What about now? You able to see, right? Hello?
Yes, sir.
Okay. So I was drawing a cube that already gone. Let draw it again. So this is my cube. At the center, I know that pressure is P. Right over here is center is P. Now, I like to figure out pressure at this surface. So in that case, what is my H? If I derive right over here, my H equal to dy divided by 2, right? Now, fx is P or Fy. If I say Fy or such say Fx as per Fourier formula, this equal to P. That means at the center is P. So what will be the pressure if at x plus h? That we will need to, I'm sorry, this we need to figure out. Okay. So if you look in the Taylor series, what will be pressure at x plus h? That will be, that means if I say, let me little bit keep it over here, this figure, or I can move it to the right over here. Okay. So I need to figure out pressure at x plus dx by 2 at this location instead of at x. Okay. So this equal to f of x. What is my f of x? P plus f prime x, my first derivative of p, right? So I can say it will be del by del x into p, or you can just say del p by del x times h. So what is my h over here? Dy by 2. So instead of x, say I put y. So this will be dy. Instead of in the bracket, I am putting p over here. Then this term will be h, right? So what is my h? Dy by 2. Dy by 2. Then the higher order term, but I am neglecting. So this is my pressure. This pressure, where it is working right over here, this surface, right? So with the arrow, I'm measuring pressure working, this pressure working in the right side. So how much pressure working in the left side, working along this direction, by same amount, just will be negative sign. That means if I copy, keep it over here, this pressure will be at distance, there will be minus, and here will be minus. Okay. So we found the pressure from the Taylor series. Now we'll do the force balance. How we can do it? We are saying right over here, summation of force along y direction, this direction is 0. So at first you figure out the force in this surface. So this distance is dx and height is dz. So what will be the area? Dx into dz. Then you multiply the area. What is the area? Is this one, and what is the pressure? P minus del P by del Y dy by 2. So I say multiply by the, this is pressure, this is the area. The right hand side is working negative y direction, so minus. How much the pressure? Right over here. This is P del P by del Y into del Y by 2. So this value into, you multiply this area. So this length is dx, height is dz. So this is the area. Okay, this is equal to 0. So you see this much pressure working in the right side, multiply the area, you get force. This is positive because working toward right. And on the right hand side, pressure is this much, and this is the area. So this is my total force is negative because working toward left side. Now you multiply by dx, dz, just simplify. So I will mention, I forgot over here, what will be dy into dx into dz. Similarly, right over here will be dx, dz. And you see this p will be out. And this one, dx, dy, dz is a volume. Even it is small, you cannot ignore the volume. So volume is very small, but it has a value. That means delta v, right over delta v. So what is over here? Half minus half x minus half x. So you will get a, and then my negative sign the left side, right hand side is 0. So you can write down this one, right? And from how the two term is over here, product is 0, is delta v times this one, but we don't know which one is 0. Is delta v 0? Is possible? Volume cannot be 0, right? So obviously delta p by delta y is equal to 0. So delta p by delta p equal to 0. What does it mean? What is it? Like if I say dr divided by dt, what does it mean? It meaning that the rate of change of r, or r is not, if this is 0, what I will say? That value of r is not changing with time. So similarly, right over here, we can say the pressure is not changing along y direction. So say fluid pressure does not change along y direction from here. How we can figure out? Right over here, I can say dr equal to 0. You do the integration both sides, then what will get? R equal to constant, right? You will get value r equal to some constant, say you got C1. Constant means value is not changing. Now, similarly, we will say along x-axis, that means the pressure is working like right over here and right over here. Okay, that will check it. So similarly, along x direction, fx equal to 0. Let me bring that figure at the bottom. Okay, so we are taking along x direction. So along x direction, pressure this side is working in negative x direction, right? So pressure is P plus delta Px plus dx by 2. Similarly, we use the Taylor series. This is the pressure. And
Sir,
yes,
sorry sir, disturb করলাম স্যার।
Oh.
স্যার দুই একজন মেবি স্যার ওয়েটিং রুমে আছে
still
স্যার।
some people waiting. Okay, let's
জি
see.
স্যার।
It's supposed to give me the pop up the window. Okay, I allow them. Okay, so this pressure working along negative x direction, and one more pressure along this surface working along positive x direction. So Siam, your mic need to be mute. Okay, so you see right over here, this is my pressure, this is area. Similarly, this is pressure and this is the volume. I put dy, what is that, this area? dy into dz, right? So why I put this on I put twice. Okay. Now this p term will be out. You have similarly this term. So you can say half delta p by delta x into del v equal to 0. And similarly, you can say from there that del p by del x equal to 0. What does it mean? No pressure is changing along x direction. That means along x and y direction, pressure is same. So what is x and y direction? You see, x and y direction mean horizontal direction, right? You see right over here. your x and y is the same plane. That means horizontally pressure is not changing, not along x-axis. X-axis this way, not along x-axis, not along y-axis. Now need to say about the vertical axis, that what will happen. So vertical axis, how many force working? You see in vertical this surface there is a pressure working downward. In the bottom there is a pressure working upward. And what else we have? Other thing, the weight of this fluid. So how can figure out the weight of the fluid? So you see pressure right over here around positive z, right? So your H will be dz by 2, and this is positive. And this force right over here working negative z direction. So this is the pressure. This is the pressure we found by Taylor series. And what will be this area? dy into dx, right? So this is the pressure. This is the, area. Similarly, at the bottom, right over here, pressure is P. What will be pressure at this surface? In that case, my H will be minus dz by 2. So this will be pressure. And this pressure working upward. So you get dx into dy. Now, the weight of the object is working downward. So how will get the weight? So weight W, if I say right over, weight W will be equal to E multiply by rho, then multiply by G, then multiply by volume. Now G rho, this is G and rho, is called gamma, specific weight of the fluid. So instead of G rho, I can put the gamma times volume. This is the weight. So weight of this fluid element working downward, the negative z direction. So this is gamma, this is volume, dx, dy, dz. Now you just multiply all the side. If you multiply all the side, then P will be out. So it will be this one in the right over here, this value right over here, it will be this value right over here. So our dx, dy, dz equal to delta volume, del V. Right over here, del V. Right over here will be gamma into del V. So now what you see? These two term, this is half x, this is half x, right? This is my x, this two term. So you'll get the one full term right over here. So you're getting one full term, then minus del V. Now you see del V volume cannot be 0. So you are getting this one. Del P by del Z equal to minus gamma or minus rho G. So what do you see? That means fluid pressure along Z direction, the one vertically is changing, is no more constant. Now, this one we can say, what is the difference between del and D? Anyone? Say, I am writing over here, del P.
ডেল্টা হচ্ছে
Yeah, go ahead. When you use this one,
স্যার ডেল হচ্ছে আমি স্যার এটা তখনই করবো যখন আমি শুধুমাত্র এক্স এর উপরে ডিফারেন্সিয়েটটা করবো সেটার ক্ষেত্রে, মানে একটা পার্টিকুলার ক্ষেত্রে। আর ডিটা হচ্ছে আমার ওয়াই এর উপরেও আমি করতে পারবো।
if you have multiple variable, then you get the partial derivative. Then you have single variable, then you got the derivative. Okay. So right over here, there's no more variable in the right hand side. That's why instead of del P by del Z, then we can say derivative del P by del Z. Okay. So del P equal to rho G Z. Right. Now, this one will integrate both sides between 2 points. Let's see how we can integrate between 2 points. I am taking 2 points, 1 and 2, right over here. And from the top surface, height of point 1 is h. And from the bottom surface, this point 1 is z1, and depth from the bottom surface, or you can say from y-axis, its distance is z2. And for point 1, distance from y-axis is z1. So what does it mean? If I think this is the top surface of the water or sea, then what will be the pressure at point 1? That means at a depth h. That we will figure out by integration. So if you integrate between right over here in the both side from point 1 to 2, then you get this one. Pu2 minus P1 equal to rho G, Z2 minus Z1. Now Z2 minus Z1 equal to what? Equal to h. So right this side you got the h. Now P2, pressure at the top, that means no pressure, that means atmospheric pressure, right? So we put our atmospheric pressure minus P1, that pressure we need to figure out. So we say P1 equal to rho GH P atmosphere. So right over here, you will get absolute pressure. You will get absolute pressure. Why absolute pressure? Because you add atmospheric pressure with this value. So this will be absolute pressure. So what is actually the okay? That means if you put a pressure gauge at the bottom of a sea or river, right over here, you put a pressure gauge. What reading he will show? He will show the reading P1 equal to H rho G, this value. So this pressure is given by a meter, by a gauge. That's why it is called gauge pressure. So with gauge pressure, when you add atmospheric pressure, then it become absolute pressure. Okay. So what you see, pressure of a object in a underwater or under fluid, it depends on depth. If depth increase, pressure increase. If depth decrease, pressure decrease. Okay. You just just read one time. Same thing what we derive. So after derivation, we are getting that if dz equal to 0, right over here in the derivative, what we found, math cut file. You see dp by dz equal to rho g. So if dz equal to 0, dz no change of distance along vertical direction, then dp will be 0. That means you are not moving along vertical direction, then change of pressure will be 0. That is saying right over here. Okay. And this equation is valid for both compressible and incompressible fluid, that dp by dz equal to rho g. Okay. And if rho constant, then what are we getting? Then P equal to rho gh. And this one is called hydrostatic pressure of stationary and incompressible fluid. Is function of vertical depth and density of the fluid. If fluid is more denser, then you'll get more pressure because density is changing. P is the linear function of density. And from this equation, you see one thing, that we are getting P equal to rho G H. Now, I am giving a pressure. I am saying, for example, in your submarine, you're looking at the pressure. You are getting pressure 5,000, say, megapascal or pascal. What will be depth of your submarine? How you can figure out? By this formula. Because A is equal to P by rho G. Or P equal to rho G equal to gamma, P by gamma. What does it mean actually? That means this pressure of any location you can express in terms of height of the fluid. If this is gamma you're taking for the water, then the whole pressure will express in terms of depth of certain fluid. That means height of a fluid. So remember two formula, P equal to rho GH, and if you have a pressure, then you can, those pressure you can convert in terms of H. For example, in some equipment manufacturer, they make the pressure sensor. In terms of direct pressure, they will give you height of the column of fluid. They will say there is a mercury on the tube, and say you are in the tube, there is a mercury, and you bought some sensor, and this pressure that is not giving directly pressure. It's saying pressure is 2 millimeter of mercury or 20 centimeter of mercury, Hg. then how will figure out the pressure, actual pressure? Formula P equal to rho GH. You put density of mercury multiplied by G, AC you convert in meter, then you will get the pressure. Okay, that means pressure can be expressed in terms of height of a fluid. Okay.